Welcome back. Today is going to be the first part of a two-part lesson. Tomorrow we'll go over the very specifics of it, but today I want to introduce you to what the topic is. We have something called the power of 0, the zeroth power. Let me show you an example. Let's say we have 3 to the power of 2 over 3 to the power of 2. Well, I know from the quotient rule that that whole thing is the same thing as 3 to the power of 2 minus 2. I'm going to write that down right here. And that's because of the fact that we have a quotient with the same base of 3, we can subtract the exponents. Well, when I have 3 to the power of 2 minus 2, I know that that whole thing is equal to 3 to the power of 0. But I also know that 3 to the power of 2 over 3 to the power of 2 is equal to 9 over 9. The reason why is because 3 to the power of 2 is 9, because that's 3 times 3. So I have 9 over 9. But when I have 9 over 9, I know that that whole thing is equal to 1. 9 divided by 9 is 1. So that tells me that 3 to the power of 0 is equal to 1. These two are the same. Now, after I write this down right here, 3 to the power of 0 is equal to 1. That makes me wonder whether anything to the power of 0 is always equal to 1. Let's look at another example to find out. Let's look at another example using the product rule. We have, for example, 5 to the power of 3 times 5 to the power of 0. I'm going to put that 0 in this lavender color to get 0. So I know that I can use the product rule here because the bases are the same. So I'm going to add the exponents, 3 plus 0. Once again, it's because they both have the base of 5. Once I do that, I know that 5 to the power of 3 plus 0 is the same thing as 5 to the power of 3 because 3 plus 0 is equal to 3. So what do we have here? We have 5 to the power of 3 on both sides of the equal sign. And we have a 5 to the power of 0 on the left side. Once again, I'm going to write this again. 5 to the power of 3 times 5 to the power of 0 is equal to 5 to the power of 3. That 5 to the power of 3 still stays there. What does that tell you? Well, that tells me that 5 to the power of 0 should probably be equal to 1. So I'm going to write that down in in blue. So 5 to the power of 0 is equal to 1. The reason why is because of the fact that there's only one number that you can multiply by itself to get that same number. And that's 1. So 5 to the power of 3 times 1 is equal to 5 to the power of 3. Let's look at one last example. Let's say we had 2 to the power of 3 over 2 to the power of 3 times 2 to the power of 2. What would this complicated expression be equal to? I'm actually going to show you two different ways to show you that everything we learned so far, the product rule, the quotient rule, everything, that's part of the same story. So I'm going to use only the product rule and the quotient rule to solve this problem. Let's say here we have 2 to the power of 3 times 2 to the power of 2 over 2 to the power of 3. So I'm going to write that down right now. And that's because of the fact that I know when I'm multiplying, I can put everything I'm multiplying into the numerator. That's the very top. Now, I have here at the top, I can use the product rule to get 2 to the power of 3 plus 2 over 2 to the power of 3. That becomes 2 to the power of 5, because 3 plus 2 is 5. And that still is 2 to the power of 3 on the bottom. So that's 2 to the power of 5 minus 3, which is the same thing as 2 to the power of 2, which is the same thing as 4. So I get 4 as the final answer. Now, let me show you using what we learned today about the 0 rule. I'm going to start by subtracting 3 minus 3 on the top because I'm using the quotient rule. And I'm multiplying that by 2 to the power of 2. Well, 3 minus 3 is 0, so I find this whole thing, and then I find that 1 times 2 to the power of 2 is equal to 2 to the power of 2 is equal to 4. Great job again today. See you tomorrow.